Santosh, thank you very much for the nice introduction. So I was told to come and talk about a kitten, and just to show you that I won't bore you with a Swiss children book about Pitschi, which I will talk about, but I am happy to hand it around because it's a nice story and it relates to my past in Switzerland. So have a look at what Pitschi is, and maybe during the talk you will get an idea what Pitschi can also be. So who we are, the Center of Microscopy is located mostly on the St. Lucia campus, but also on a second campus. We have 5 different sites, and we look after instruments. So we're the custodians of the transmission, scanning electron microscopy, the analytics related to it, to X-ray tools, and also a novel imaging lab where we actually develop instruments or missing parts to instruments which we think should be ready for the future scientific uses. So if you're looking at all these instruments, for sure not in the light microscopy field, so I'm sorry about that. And the second one is around 68 to 75% of our usage comes from mining, engineering, material science, and only 1/3 roughly is life sciences. So we had to find other solutions. And you see we have a large team. We look after these instruments. Without them, all these instruments would mean nothing. But there's one big problem we faced with all these instruments and being at different locations across campus. We had the same issue as I described before. Where does our data end up? We have around 700, 750 users throughout the years. And quite often we got a call, I forgot my data. Can you send me a copy of my data, or can you help me to find out what my data is? And that's not our job as a facility operator. So quite a long time ago, if you just were the only researchers doing your research, like Ehrlich here in his workroom, he could pile up his papers, and he had a coordinate system, X, Y, where things are, the topics, and the time was just in the z-axis. So that helped him to find, and he was obviously very good as people who reported from him. My time in industry ended up that we had a lot of copies of data put into modes, which are fire protected, because nobody trusted back then, 20 years ago, the computer science. So this is really not working. And you can ask yourself the question, how long does it take to find something in here? And especially if you ask a postdoc or a doctoral student to go and find something in Ehrlich's Zimmer, there's no way that somebody will ever find something. So we all agree that we need databases. And I bring this up more or less as a workflow reminder. So if you do experiments, you run, first you cultivate your cells, you do sample prep, and then you start imaging and then image processing. All the blue double arrows, for me, are areas where you can extract metadata. And if we are clever in extracting metadata as we do the experiments, we should be able to throw away the images because we can reproduce data. That's another statement I would like to do. And I will come to that at the end of it. So we were always looking for databases which could actually handle this. UQ already had a beautiful research data management system, which was awarded for a prize. So they gave all the researchers basically an area to store their data. Nearly unlimited, well, in the beginning, now it's limited, as we know, and others actually. But in principle, people just dumped their files there and couldn't find it in the end anymore. So you need somehow a structured database. And the other thing which we faced at UQ, and especially because multiple buildings have been built at different times, that there are different speeds of networks, different hubs in between, different switches, different firewalls. This will all cause problems if you start to think about a centralized database. Then I show you just that we had this. So this was the starting point. And I was coming from industry, so I was familiar with laboratory information management system. And I just wanted to start to buy one. And then ITS said, no, you don't get it. For several reasons, too costly, too much cost during the year to operate it. And then that's when we actually started to engage with people, which are listed here, from the Research Computing Center, from ITS, and from us, CM, find a database which can harvest data not only from light microscopes, not only bioformats, but any kind of analytical data, so mass spec imaging, X-ray data sets. And we found a solution in the United States, Clowder framework, and I will talk a little bit about the Clowder framework. As you know, Clowder is a group of cats, and if you have to do something with the Clowder network, you have to give a name of a cat. So I go back to now Pitschi. Pitschi has a very complicated name, particle imaging depot using storage caching infrastructure. Caching because we can immediately send data to the HPC cluster for processing. And that's very important if you want to be efficient. So what is Pitschi? The Pitschi objectives was it should be easy for the end user. I just showed this diagram. If you implement something new, you have to make it not only possible, you have to make it easy so that people take it up, and you have to take it to normative. That's where we are. It took us 4 years roughly to get to the area where we actually have a larger pickup. One storage collection project, we moved away from a user has his account. They actually apply for a project, and with this project, they get a project number, and they can have their own RDM for this specific project, because the researcher can have several projects. So that was also a change in habits as we went along. So what is Clowder? Clowder is an open source data management system developed by the National Center for Supercomputing. So I had nothing to do with that. We found that by good relations from David Abramson at RCC, and we tested it and compared it to different LIMS and other systems. And it was in the end, the system we actually decided we want to go forward. Some of you may have heard about 4CED. It's an imaging database which has been already established at some material science lab in the States. And it is able to handle any data sets out of these research areas. So it has already a structure which allows handle complicated data structures, basically. So you have access control to data. It's organized in a way that you have spaces, and we define now spaces as our project. And on the spaces, you have different folders. These folders are your experiments where you collect all your data sets. For Pitschi means once people assign a project and apply it at CMM, we use PPMS also for the booking. This becomes our project number, which has then an affiliated RDM structure, a queue collection. And from then on, for the users, they have to do nothing more than just go to the microscope, book, and actually get their RDM delivered. So that's what they interact with. They apply with the project. We assign a queue collection to it. Queue collections because it's an HPC accessible cached device, basically. And in the end, in Pitschi, they have their spaces organized. Happy to go into more detail later. What Huang actually did as he was working for us on a project, and we hired a few people doing different ARDC funded grants, was basically developing a thumbnail, because most imaging scientists like to work with images. They scroll through images and see things much faster than reading file names or typing names in. So we have also now within basically Clowder environment an image browser available if you don't trust your keywordings. We can upload files through a website, or we can upload files directly from an instrument, as you can see here. The client goes to the computer, logs in with the PPM as a project number, and from then on, the computer knows where your RDM is, where the data has to end up. It took us a while to sort out because we have different computers, we have different operating systems and all that stuff. But once data is shuffled into the RDM, as you see, we don't copy data. It has actually basically just a name or a reference number, whatever you want to call it, which is then referenced as Clowder starts to digest information from RIMS and other information sources. So actually, Clowder does nothing else than digesting the location of your files and get the information, the metadata from your project from RIMS, from the database, or you could also harvest the information from a lab notebook. So this is basically, if you're not at the instrument, but you have files which you want to preserve, you can do that on your computer and upload it through a web browser as well. This is the workflow usually as we have data collection, data storage, and then archiving. And then you have to think about how you want to archive and upgrade and curate also these data stacks. And that's our next step, basically. But the user only interacts at 2 points, basically. When he signs up to the instrument, when he makes a booking in his calendar, comes to the instrument, from then on, everything is automatized. We push data thanks to queue collections. UQ has been established, and it's a big gift for us because that costs millions to establish. We push data automatically into these collections. So once it's in RDM, the first email gets filed to the user, means you can find your data now unstructured on RDM. They are safe. Now we have 3 copies, and UQ takes care about the safety and of the data. So we don't have, as a facility, to run backups and check where files are for clients. The second mail happens probably around 10 minutes later, when Pitschi actually has all the information digested and says you can now go and use the web browser in Pitschi and find your data set. So that's the first part. The second part is actually once you have your data set, you want to process it. And we were engaged with virtual desktops, which was there as I came to Australia, a project which came from Monash research, over Sea Devil and others. And now we have the luxury that we have a HPC computer at UQ, which on demand can start software packages. And I don't go into details, but Bunya is our newest HPC cluster, very powerful, but on demand, you can actually now set up graphic interfaces and start processing data. Or if you work with AlphaFold or CryoSpark, you can even have semi-automatic processing happening in the background on the HPC cluster. So not on a computer in your facility, not on a computer in a lab from a researcher. And we are very fortunate that UQ actually has all this infrastructure available. But that's a way that you can actually quickly get your data up and start working with it and be safe because it's stored and backup is taken care of. We don't know how it stays 7 or 9 years on site, but that's policy which has to be implemented. We thought that it takes us maybe 6-8 months. It took us more than 12 months. We had to get into really nitty hardware exchange on our network because of bandwidth issues. We had to deal with various operating systems, and there was a big change in behavior. People had to accept that they have projects and they have to book upfront and they have to give some information upfront available, otherwise their data set would be not enriched. So you can see some numbers here. In 2022, we had 22 instruments. We have now a little bit more than 54 instruments online, and more than 4 million data sets have been already acquired. With the crystallization facility, we are more than 0.5 petabyte of data already on RDM, just on the Pitschi control. So that tells you that Clowder is extremely powerful. So what next? I told you that Pitschi was always dreaming of being something else in this children book. So the next phase is actually the rollout of Clowder 2. So Pitschi has a chance to become a big cat because that's the plan of the HPC community in the US. Rollout Clowder 2 should happen at the end of this year, which gives you much more web interfaces, searchable links, customizable metadata, so easier way to digest data from other sources when researchers are willing to share their information with the data set. We hope to roll it out and be able then to actually have an environment which allows you then to use Jupyter notebooks, Jupyter hubs, and also Slurm on HPC, so that you are ready to really start processing on demand once data is digested in Clowder 2. Yeah. We had many challenges. I would say don't underestimate the change of culture. The change of culture, if you implement something new, gives you a lot of pushback by staff members, by individuals. You have to take a lot of time to convince people that you implement something which they benefit. Users which now use it, they are happy. They don't ever have to copy data anymore. It's a slow process. If you think about terabytes of data produced on a cryo-EM, you would have to copy it to a processing environment. That can take a whole night or a whole day. That doesn't happen anymore. And my hope is basically, if you look more and more at data, and that's already an old publication around 2018, we know that data centers have been growing massively also with AI. So why would we actually store all raw data? If we have processed it and have all the metadata stored, science tells you you should be able to throw away most of the large data and be able to replicate or duplicate actually your experiment again, because you have all the information you need to do that. I would say keep only the published data and your metadata in future. That would be a challenge. Does it work with AI? Probably not. If you think about pathology, where you want to have a large data set volume to train computers to find certain patterns, it doesn't. So these are our partners. I would like to thank everybody. I would not stand here if UQ ITS didn't have told me you can't buy a LIMS system, and the whole project would never have happened. So you see, sometimes things have to be, at the moment, nasty, but it turn into something good. And I'd like to thank you, Pitschi. And finally, I would like to invite you to come to the Asian Pacific Microscopy Congress, which is in February next year. We also have a workshop if somebody really wants to learn more from the people here, what Pitschi can offer you to the community and how this has been implemented. And that's my talk. Thank you.